Alright, in this video we're going to take a look at finding unit vectors and what those are. So a unit vector is a vector that has a magnitude or a length of 1. The notation for a unit vector is the vector name along with this little hat or caret symbol written directly above it. So here I have, for instance, vector v in blue, where the initial point is the origin and the terminal point is somewhere in the first quadrant. So, maybe this has the components 1 and 2 for our original vector here in blue. Well, a unit vector is going to be parallel to the original vector. So they're both pointing the same direction, so they're parallel. But the unit vector here, which I have in a bolder arrow, has a magnitude of 1. And as we can see around this circle, that the length of this unit vector is going to be 1. I and j that we've talked about already are unit vectors where I is 1, 0, so that would be right here on the x-axis, and j is at 0, 1, so that would be up here on the y-axis, or on the positive y-axis. But two things to keep in mind with unit vectors: number one, their magnitude is 1, and number two, that they're parallel to the original vector. And if we make the initial points at the origin, then the unit vector will always lie on top of the original vector. So we get that unit vector by dividing the magnitude of vector v, or by dividing v by its magnitude. So let's say this had a magnitude of 2 originally, then we would want to take that magnitude of 2 and divide it by itself to get a magnitude of 1. Now keep in mind that when you divide one side of a triangle by a number, you got to divide all the sides of the triangle by the number. So if we divide the hypotenuse of this triangle, this right triangle here, if we divide the hypotenuse by 2, we also have to divide the height, or the y component, the vertical component, and the base, or the x component or horizontal component, by 2 as well. So whatever we do to one side, we got to do to the others. So in addition to the vector itself getting divided by its magnitude, both the horizontal x and vertical component y also get divided by that magnitude. All right, so example 3, we have finding a unit vector for each of the following. We're going to start with vector v is at 5i minus 12j. So our first step is to find the magnitude of this vector, and we do that by taking the square root of 5 squared plus 12 squared. 5 squared and 12 squared is 169, and taking the square root of 169, we get 13. So the length, or the magnitude of this vector, is 13. So to find the unit vector, we just have to divide 5 and negative 12 by that length of 13, and we get our unit vector v is 5/13 I minus 12/13 j. And if we wanted to, we could, if we found the magnitude of this unit vector, 5/13 squared plus 12/13 squared, and then square root of that, we would get 1. And this vector here, 5/13 I minus 12/13 j, is going to be parallel to this original vector. So if we had the initial points at the origin for vector v and its unit vector, we would see that this unit vector lies directly on top of this original vector. All right, example B, we have vector w is at 4, negative 3. So once again, we're going to find the magnitude of vector w, 4 squared plus 3 squared, again ignoring the negative. That's going to give us square root of 25, which is 5. So the magnitude of vector w is 5. And then dividing the horizontal and vertical components by 5, we get a unit vector for vector w is at 4/5, negative 3/5. All right, our last example in this video is going to be vector d, 7i plus j, or 7i plus 1j. So magnitude of vector d is going to be 7 squared plus 1 squared. Don't forget there is a 1 in front of the j. 7 squared plus 1 squared is 50. So we're going to take the square root of 50, which we can simplify that as the square root of 25 times the square root of 2. So square root of 25 is 5, and square root of 2 is the square root of 2. So our exact simplified answer for the square root of 50 is 5 times the square root of 2. So we're going to take each of the components, the horizontal component of 7 and the vertical component of 1, and divide them by 5 times the square root of 2 to get unit vector D. Now, we don't like to have square roots or any kind of radicals in the denominators, so we're going to have to rationalize these denominators, which is just all we have to do is multiply the numerator and denominator by, in this case, square root of 2. That'll get rid of the square root of 2 in the denominator. So for our horizontal component, we have 7 times the square root of 2 over 5 square root of 2 times the square root of 2. And 7 times the square root of 2 is 7 square root of 2. 5 times the square root of 2 times the square root of 2 is 5 times 2, which is 10. For our vertical component, 1 over 5 times the square root of 2, if we multiply the numerator and denominator by the square root of 2, we get 1 times the square root of 2, which is square root of 2. And again, 5 square root of 2 times square root of 2 gives us 10.